Let's talk about logarithmic graphs. So by now you should know that a simple logarithmic relationship has the form y equals to log ax. The function y equals to log ax is the inverse of y equals to ax. And I'll explain what the inverse means. Alright, so to get the idea of what inverse means, right, I want to sketch y equals to 2x. Just a rough sketch. So that's an exponential. So it'll look something like this. Okay? Where the intercept is like 1. So y equals to log 2x is the inverse of this, and I'll show you what it means. Y equals to log 2x looks like this. Okay, where the intercept is 1. Now, what's interesting, right, is if I put a line here, you'll see that it's reflected, right? And because it's reflected, these are the inverse of each other. So y equals to 2x is the inverse of that. Y equals to log 2x is the inverse of that. And this line is y is equal to x, by the way. So it gets flipped on y equals to x. All right. What's also cool about this, right, is that coordinates are also flipped. So, for example, this point right here, oops, is 1, 0. Okay. And the flipped point on the exponential is here. Okay. And that is 0, 1. So, as you can see, everything flips. Okay. Both ways. And so this is very important to note that for y equals to log ax, right, the x-intercept is at 1. So if you see here, right, the x-intercept touches 1. The asymptote is x equals to 0. So what that means, right, is that this logarithm, if you can see that, will never touch the y-axis. Also, as x approaches infinity, so does y. So as x approaches infinity, so does y. And if you look at this, right, you can see that it will infinitely like go upwards, right? It won't ever like go back down. Okay, it's just continuously going up. Here we're asked to complete a table of values for y equals to 3x and y equals to log 3x, all right? And this will be used to draw our graphs. I'm not going to go through the first table values because that one's pretty easy. You just got to sub in the numbers, but I'll go through the second table values. And so to do the log ones, right, as I mentioned before, it's the inverse. So remember how like we could swap the two coordinates? Here you can do that too. So you see how this is 1 over 9, and here we have 1 over 9? I can just write minus 2 here. Okay, same thing, this is flipped, minus 1, 0, 1, and 2. And they work out really nicely. Here I asked to plot the graph, and it's very easy to do. You just gotta plot these numbers like you usually would. I'll just quickly go through it. Like I'm not gonna show you how to do this, but I'm just gonna plot it. So this is what your graph should look like. And you can see that's kind of right because they kind of flipped on y equals to x, right? And so it looks good. All right, so just a few more questions. For each graph, state the equation of its asymptote. So I'll just write it here. For y is equal to 3 to the power of x, the asymptote, right, is y is equal to 0. Okay, the x-axis. So y is equal to 0. Okay, and you'll realize something very cool. So for y equals to log 3x, remember, it's kind of like the flipped version. So if you can think of the flipped version of y equals to 0, that's going to be x is equal to 0. Okay, the y-axis. Okay, cool stuff. State any limitations for the input values for y equals to 3x and y equals to log 3x. So for y equals to 3x, so the input values, they just mean x values, like what can the x values be? And in this case, right, for y equals to 3x, they can be all of them. So all real x. You don't, all real x just means all real numbers, okay? Because there's something called imaginary numbers, but I won't go through that. And for y equals to log 3x, the input values are different because they can't be all real x, right? It only covers like half of it. And specifically, x greater than 0. Okay, so the asymptote is at x is equal to 0, so it can never be at x is equal to 0. If that makes sense. Okay, it always has to be greater than 0 for x. Now, for this question, here it says state any limitations for the output values, so the y values, for both of these graphs. Okay, so for y is equal to 3x, right? So for the exponential, you can see that the y values, right, they always have to be greater than 0. Okay, it can never be like -1 or -2. It has to be oops, y greater than 0. Okay, but and of course you can like kind of figure if we have the logarithm version. Okay, it can be all real y. Okay, so you can see that all of these like limitations and asymptotes they're essentially just flipped. Okay, so all real y. And that's the power of inverse, I guess. All right, so now I'm going to be talking about moving the log graph up, down, left, right. All right, so let's talk about moving the log graph up, down, left, right. For this graph, y equals to log a x minus h plus k. If you have this form, right, it will move the log graph h units to the right, okay? And it will move the log graph up k units. So this is just the regular y equals to log ax relationship. And so if you wanted to move it to the right, like let's say you wanted to move it to the right 2 units, then, you know, let me do it in a different color. Your relationship will look something like this. I should put brackets in so it's more clearer. All right. And what that will look like is this. So this whole thing moves to the right 2 units. So it will be at 3, the intercept. And it'll look exactly the same. But it's just shifted to the right 2 units. Okay. What's also important to note is that the original asymptote is that x is equal to 0. And so now, since we moved to the right 2 units, the asymptote will actually be at 2. X is equal to 2. Okay? And let's say you wanted to move it up 2 units, right? So that would be y equals to log ax plus 2. Okay? So the intercept, right, would jump by 2. So it'll be here somewhere. Okay? And then it'll look something like this. Okay? So it's just moving up 2 units. Alright, so here we're asked to sketch a graph for the following log equations, labeling any axis intercepts, okay, and at least one other point. I probably won't do the other point, but it's fairly straightforward on how to do that. And we'll also ask to sketch and write the equation of the asymptote. Okay, so it's fairly straightforward what you need to do. So the original log graph, right, looks like this. Okay, so this is the original. And you just want to translate it the way it's written here. Here we have y equals to log 2 x minus 3. So we know from this dot point, right, it will move right h units. And so in this case, h is 3. So it'll move 3 units to the right. So it'll be at 4. Okay. And then it's gonna move up 2 units, right? Because it's k. It tells us to move up k units. So it'll be like 2 maybe. And so this will be your new intercept. Or not so the new intercept. It's more so this point. You know, I'll do it in red. This point right here has been translated here. And then you just want to draw the same curve. Also, I'm just going to label the asymptote. So we know that it moved 3 units, right? So the asymptote will be at 3. And I'm just going to label it here. All right, and then I'm just going to draw the translated graph in blue. So it looks something like this. Whoops. So we've already done the second part. I'll just label it so that is x is equal to 3, right? But we haven't done this part where it says label any axis intercepts, okay? And we know it touches the x-intercept, okay? Now, for the x-intercept, y has to be equal to 0. Okay, that's just a known fact. So I'm going to be solving an equation. Here we have 0 log 2x minus 3 plus 2, all right? I'll just, and then what you want to do is you want to bring this 2 over, so minus, so we have log 2x minus 3 equals minus 2, all right? And if you remember from log laws, right, I can write this as 2 minus 2 equals x minus 3. And so x is going to be equal to 3 plus 2 minus 2. X is equal to 3 plus 1 quarter. X is equal to 3.25. And so this intercept right here is at 3.25. All right, so I know that was a lot to digest, especially for the translation. But yeah, hopefully you could at least get something out of this.